students, Assalamu alaikum. I am Professor Naveed Asim, Department of Physics, Government Postgraduate College, Okada. Dear students, today's lecture is about alternating current, chapter number 16 of second year. This is the first lecture that I will try to deliver to you. Dear students, alternating current. It is that current which is produced by a voltage source whose polarity keeps on reversing with time. It is that current, its definition, it is that current which is produced by, which is produced by a voltage source, by a voltage source whose polarity whose polarity keeps on reversing with time, keeps on reversing with respect to time. This is known as alternating current. Alternating means changing current. Alternating means changing current. So dear students, its wave shape is given by this. On x-axis, there is a time interval t, upper plus voltage, minus voltage, zero voltage. Its wave shape is just like that. This is a one complete cycle of AC. This is one complete cycle of alternating current. Upper portion is known as positive half cycle. Lower portion is known as negative half cycle. So, the frequency of AC supply produced by WAPDA is 50 to 60 Hertz. Students, as you know that the unit of frequency is Hertz. Number of cycles, AC cycles completed in 1 second is known as its frequency. Now its symbol is represented by this shape or simply this. This means that you are dealing with alternating current. In case of this is AC, alternating current. So in case of direct current, dear students, its symbol is just like that. Bigger line represents positive, smaller line represents negative. This is a symbol of a DC supply. Cells, batteries provide DC supply. UPS battery, as you all know, its positive and negative terminal. This all is about direct current. Dear students, direct current DC, whereas today's lecture is about alternating current, changing current. The frequency of DC supply is 0. The frequency of DC supply is 0, whereas frequency of AC supply provided by WAPDA is 50 to 60 Hertz. Now, if you attach it with a circuit, simpler circuit, AC supply provided by WAPDA plus minus and passing through a resistor R. So the direction of current, dear students, the direction of current is always from positive towards negative. So this is from positive to negative during positive half cycle. बेटा ये जो आपको बताया जा रहा है ये ड्यूरिंग पॉजिटिव हाफ साइकिल है. दिस इज फॉर पॉजिटिव हाफ साइकिल. एंड इन टर्म्स ऑफ नेगेटिव हाफ साइकिल, upper side becomes negative, lower sides become positive, same resistance, represented by R. Now students, the direction of current is from lower to top, positive to negative. So as you see in this example, that during positive half cycle, current flows from positive to negative, means clockwise direction, and in case of a negative half cycle, the direction of current changes or reverses, which is from again from positive to negative, but in the anti-clockwise direction. So this is the explanation for the alternating current. So in terms of time period, the time required to complete one cycle of AC is known as time period. The time required to complete one cycle of AC is known as time period. So during time period from 0 to T by 2, T by 2 means half of the time period, that time interval, that 0 to T by 2, current, the direction of current is clockwise, whereas time from time interval T by 2 to capital T, the direction of current changes in anti-clockwise direction. So dear students, time period means, what do you mean by time period? Again, the time required to complete one cycle of AC is known as time period. It is represented by capital letter T. And what about frequency? The number of AC cycles completed in 1 second is known as its frequency. And the relation between two is frequency is equal to 1 over T, time period. So dear students, frequency is the reciprocal of time period, or inverse. T is equal to 1 over F. Time period is the inverse relation of frequency. So uh, waveform of alternating voltage. Dear students, now we will study about waveform of alternating voltage. Waveform of alternating voltage. The most common source of alternating voltage is an AC generator. AC can be produced by AC generator. The output of that is V is equal to V naught sine omega t. Whereas dear students, omega is equal to 2 pi f. F is the frequency, 2 pi is a constant. So omega is equal to 2 pi f, or omega can be written as omega is equal to 2 pi multiplied by f is equal to 1 over t, which is equal to 2 pi over t. Omega is equal to 2 pi over t. So V is equal to V naught sine 2 pi over capital T and multiply by small t. This is the equation number 1. Dear student, V is known as instantaneous value of voltage. Dear students, V is known as instantaneous value of voltage. Instantaneous value of voltage. What does that mean? The value of voltage at any instant of time is known as instantaneous value of voltage. Whereas, what do you mean by V naught? V naught is the peak value of voltage. Let's see. What do you mean by V naught? V naught is the peak value of voltage. This is positive peak. This is negative peak. So dear students, I think you can understand. What do you understand by difference between V and V naught? V naught is the peak value of voltage, maximum value of voltage, whereas V is the instantaneous value of voltage. Capital T and small t. Capital T is the time period. Time required to complete one cycle of AC is known as time period, whereas small t, just any time that we can measure. So putting the values, case number one at t is equal to 0. When time is equal to 0, what will happen? V is equal to V naught sine 2 pi over capital T and small t. By putting t is equal to 0, V is equal to 0. So first value we will get is V is equal to 0. Case number 2, when time interval is equal to t by 4 at t is equal to capital T by 4. T is equal to capital T by 4. So putting these values, V is equal to V naught. Putting this in equation number 1, 2 pi over capital T multiply by small t is t by 4. After cancellation and solving, capital T cancels with capital T, 2 and 2 4. V is equal to V naught sine pi by 2. Sine pi by 2 means sine 90 degree, which is equal to 1. So sine pi by 2 is exactly equal to 1. So V is equal to V naught. So second interval at case number 2, dear students, as you can see the wave shape. Firstly, t is equal to 0, V is equal to 0. At t is equal to t by 4, V is equal to V naught. So we move that at that point peak value of voltage. Now dear students, case number 3 at t is equal to t by 2. So putting these values in equation number 1, V is equal to V naught sine 2 pi over t and small t is capital T by 2. T cancels with T, 2 cancels with 2. V is equal to V naught sine pi. Sine 180 is equal to 0. So V is equal to 0. So in case number 3, as you can see, V is equal to 0. V naught again 0. Again 0. Now this is case number 3. Now moving forward to case number 4. Case number 4. Case number 4. In case number 4, at t is equal to 3t by 4. Putting these values in equation number 1, V naught sine 2 pi over capital T and multiply by small t. Putting this in equation, V naught sine 2 pi over capital T, small t is equal to 3t by 4. T cancels with t, 2 to the 4. V is equal to V naught sine 3 pi by 2. By solving sine 3 pi by 2, sine 3 pi by 2 is exactly equal to minus 1. So V is equal to V naught minus 1. V is equal to minus V naught. So one page previous, V is equal to minus V naught. That point is equal to minus V naught. Now last case, which is case number 5, at small t is equal to capital T. Capital T is the time period. V is equal to V naught sine 2 pi over capital T, small t multiply by small t. Putting this value, sine 2 pi over capital T multiply by t is equal to capital T. So dear students, you can see t is equal to capital T. T cancels with t. V is equal to V naught sine 2 pi and You should know that sine 2 pi is equal to 0. V is equal to V naught multiply by 0. V is exactly equal to 0. V is equal to 0. So dear students, V is equal to 0 means again 0. So in 5 cases, one time again repeat, V is equal to 0 at t is equal to t by 4, V is equal to V naught maximum point. At t is equal to capital T by 2, V is equal to 0. Third case. Case number 4, t is equal to 3t by 4, V is equal to minus V naught. V is equal to minus V naught. And in case number 5, as t is equal to capital T, time period, then V is equal to 0. This is the variation of voltage. Dear students, this is the variation of voltage with time, and angle theta is shown in figure. Now we will see the angles. 0, this is in angular form 2 pi, this is pi, 0, pi, 2 pi, pi half, pi by 2, and this point is 3 pi by 2. So this is variation of angle theta. This curve is known as sine curve. This curve is known as sine curve. The output voltage of AC generator varies sinusoidally. As you can see, this is sinusoidal variation of voltage with respect to time. This is plus voltage plus V, down minus voltage, and this is x axis time interval. The main reason for the worldwide use of AC is that it can be transmitted to long distances at a very low cost. बहुत कम खर्चे पर एसी को अल्टरनेटिंग वोल्टेज को हम आसानी से एक से दूसरी जगह पहुंचा सकते हैं, और इसी को हमारा वापडा इस्तेमाल और यूज़ करता है. तो डियर स्टूडेंट्स, I hope that you will understand my today's lecture, which is about alternating current. So I hope that you will learn from this lecture. So be prepared for the next one on a daily basis. That's all for today. Allah Hafiz.